For the last 5 class periods, we have been looking at how to simplify and then solve rational functions. Today what we're going to do is we are going to learn how to graph them. And we're also going to learn some transformation rules for graphing these functions as well. Our do today is f of x is equal to 2 over x plus 2. So here in about 30 minutes we're going to know how to graph this function using some transformation rules. For this warm-up activity, could you please pause it and work through these 4 questions? Now that you've worked through these 4, let's go ahead and uncover and see how you did. When you took the first one, you graphed it into x minus 3 and x plus a 5. Set each factor equal to 0 and solved, and you should have got x is equal to negative 5 and x is equal to 3. For the second one, you factored into x minus 7, x plus a 7. And when you solved each of those factors, plus or minus 7 would be your solution. For number 3, you factored the top into x plus a 4, x plus a 1, and you factored the bottom into x minus 1, x plus 1. And when you divide it out, you should have been left with this. Now remember to always restrict the domain. And for number 4, you factored the top, you factored the bottom, divided out, restricted the domain, and this was your answer for this one. Alright, well let's today go into some new material. On this slide, it shows the new vocabulary that we're going to be learning over the next 2 class periods. So in your Cornell notes, if you could please write these on the left side, and as the lesson goes along, we're going to be defining each of these. So let's begin with a rational function. A rational function is simply a function whose rule can be written as a ratio of 2 polynomials. Now, if we review back to, say, a polynomial function, remember a polynomial function, the common function or the parent function for a polynomial function, remember, was f of x is equal to a times the quantity x minus an h, the quantity squared, plus a k. Well, this function right here, this is the common function for a rational function, where this function right here was the common function for a parabola. Now, this function up here has a name as well. Like this one is called a parabola, this one up here is called a hyperbola. This slide shows what the common function is going to look like on the graph. So, for example, you're going to see the graph, and it runs right along here in the first quadrant and in the third quadrant. Notice the graph becomes ever close to the x-axis or ever close to the y-axis, but it does not touch it, at least not at this point with the common function. Now, the x-axis, that is known as a horizontal asymptote, and this y-axis in this situation is the vertical asymptote. So let me go ahead and uncover this here. So in this situation, the vertical asymptote happens to be x equals 0, and the horizontal asymptote is going to be y equals 0. In this slide, we're going to look at the transformation of the a and the h and the k and how it affects the hyperbola. But before we do that, let's go ahead and review the parabola. So remember, for a parabola we had f of x is equal to a times the quantity x minus h, the quantity squared, plus k. Now, remember the a value is what vertically shrunk or stretched it. Likewise, the a value for this one will vertically stretch or compress it as well. Remember, if the a value was negative, less than 0, remember it reflected across the x-axis. Alright, now, what did the h value do? Well, the h value, remember, in the parabola is what moved it left or right. If you saw minus h, remember it was plus h. If you saw plus h, it was minus h. So remember, it was always opposite of what you saw. Likewise, with the hyperbola, you have an x minus an h. So if you see a minus h, that means it's going to be a positive h and it's going to move it to the right. If you saw a plus h, remember it was a minus h, and it moved it to the left. Now, the k. In looking at the k, the parabola, it was exactly what you see. If you saw plus k, it was exactly what you see. So the k value vertically translates the graph. If it's a minus k, or k is less than 0, it moves it down. And if it's a positive k is greater than 0, it moves it up. Let's take a look at this, and let's see if we can see what the h and the k value for a couple examples will be. If you look here, you see x plus a 2. Because it's plus 2, that means the h value is going to be negative 2, which means it's going to move it 2 units to the left. Which means my graph will look like this. Now notice in blue is my common function, and in red, notice it shifted it 2 units to the left. Okay, in the second example, I look here, I see a minus 3 here. That means it's the k value. So it's exactly what I see. So my k is going to be equal to negative 3. And my translation is it's going to move it 3 units down. So look again in blue, that's your common function. And notice what it did here. It moved it 1, 2, 3 units down. For this slide, I want you to pause it and work through each one of these in the examples A and B, and then we're going to look at them together here when you're finished. Okay, well first of all in the first one, hopefully you realized that your h is going to be, you see plus 4, so it's going to be minus 4, so h equals a negative 4, which means it's going to translate 4 units to the left, and the function will look like the one shown right here. For the second one, I do not see an h value, but I see a k value. I see it's a plus 1, which means it's exactly what we see. So you're going to see a k value of 1, meaning it translates at 1 unit up, and the function will look like this one. In this slide, we're going to talk about the asymptotes of the function. Now, first of all, let's review the h and the k for a moment, and then we're going to talk about the asymptote. The h value, remember, is what's on the denominator. Now, remember this, when we simplified rational expressions, was what restricted the domain. This here is our k, and again, it moves it up and down. All right, so the vertical asymptote is going to be the restriction on the domain. So your vertical asymptote is the line x equals h. So when we did this over the last 5 class periods, and you simplified, you factored it, you simplified it, you took each of the denominators, set it equal to 0, and solved, those values were actually the asymptotes to the function. And the domain of this function is going to be all the real numbers except for those h values. Now, when we look at the horizontal asymptote, your horizontal asymptote is going to be it's going to be y equals the k value. So this is going to be your horizontal asymptote, which means your range is going to be all the real numbers except for where y is not equal to k. On the next 2 slides, we have some example problems that we're going to work through. These are going to be very similar to what you're doing in your assignment next class period. But for right now, when you first attempt this problem, I want you to look at the a value. And you see that it does not vertically shrink or stretch it. Okay, then I want you to look here. Is there an h value? It's opposite of what you see, so you're going to say yes. H is going to be negative 3. That means we're going to have a vertical asymptote at x equals the h value, so it's going to be x equals a negative 3. And your domain is going to be all real numbers except for negative 3. And this is how we will write it in set builder notation. Then we have our horizontal asymptote. Now remember, we got our horizontal asymptote by looking at the k value here. I see that k is going to be equal to a -2, which means my horizontal asymptote is going to be y equals k, or in this case, y equals -2. So let's uncover that, y equals -2. And my range is going to be all real numbers except for y equals -2. And here's how we'll put that in set builder notation. Now, remembering the asymptotes, okay, x equals -3, y equals -2. Now, I want you to pause this, pull out your graphing utility, and graph this. Again, remember to put parentheses around anything you put in the denominator, and then in a moment we're going to check to see how you did in graphing it. Now that you have graphed this on your utility, this is what it should have looked like right here. Let's go ahead and we're going to draw our asymptotes in there. So first of all, I have my vertical asymptote, which comes right down here, and it's going to be at x equals -3. Now make sure you label it x equals -3. And we're going to have my vertical asymptote, my horizontal asymptote, which is going to run right through like this here. And it's going to be at a y equals -2, and that's what our graph is going to look like. Let's go ahead and look at this one now. In graphing this one, I want you to pause it for a moment and walk through this, and then we're going to talk about it. Now that you've gone through this, let's go ahead and first of all, let me uncover a few of these things here. I see g of x is equal to 1 over x. We have a -3. That means my h value is going to be, I see a -3. H value is going to be a +3. My k value, I see -5. It's going to be k equals -5. My vertical asymptote is going to be x equals my h value. My h value is a 3, so x equals 3. That means my domain can be anything except for 3, so we'll write it in set builder notation as x, such that x is not equal to 3. My horizontal asymptote, remember, is going to be y equals my k, so y equals -5, meaning my range is going to be all values except for y equals -5. Now, remembering my asymptotes. Remember my asymptotes are x equals -3, y equals -5. And now I want you to pause the video for a second, and I want you to graph it using your graphing utility. Now that you've done it with your graphing utility, this is what it should show right there. Now, let's remember and draw the asymptotes in there. So my asymptotes, my vertical asymptote is going to be at x equals a +3. So I'm going to draw my asymptote right down there like that. And let's label it. So it's going to be x equals a 3. My horizontal asymptote is going to be at y equals -5. So it's going to be right along in here. And let's label that. So that is y equals -5. And that's what our graph looks like. That will pretty much wrap it up for today. If you would please write down this assignment right here, have that ready to go, so when you walk in next class period, we're all going to be ready to work on that assignment. Also, don't forget to write your summary in your Cornell notes. And next class period, we're going to spend some more time graphing more functions that look a little bit different than what we did today. All right. Have a good day, and we'll see you in class next class period.